We will later talk about the vapor pressure, but particles of a gas move in all possible directions in straight lines. During their random motion, they collide with each other and with the walls of the container, and pressure is exerted by the gas as a result of collision of the particles with the walls of the container. Okay, so whenever there is pressure, what does it mean? How do we calculate the pressure? Whenever there is steam coming from boiling water in front of you, you boil some water and there is steam coming out of it, and you just take out a utensil and keep it on the steam, upon the steam, so you experience a pressure, right? So that's how it is measured. If there is liquid will strike the container in which it is kept. Solid will not, but liquid will, because it takes the shape of the container in which it is filled, or the gas is filled, because both are fluids. So they will exert certain pressure. So that pressure is actually called pressure. So here also same thing is told, that if there is an assumption that particles of a gas which are in constant motion, they move in straight lines because they collide with each other and also with the walls of the container. That's how the pressure is developed. Fifth is, collisions of gas molecules are perfectly elastic. This means that total energy of molecules before and after the collision remains the same. There may be exchange of energy between colliding molecules. Their individual energies may change, but the sum of their energies remain constant. If there were loss of kinetic energy, the motion of molecules will stop and gases will settle down. This is contrary to what is actually observed. So, if we see that collision of gas molecules are perfectly elastic. Why do we say that? Elastic means that the total energy of molecules before and after will be equal. And before and after, if it is equal, so we are just saying that there is an exchange of energy between colliding molecules. Their individual energies are changing, but the sum of their two energy levels remains a constant. Before and after collision, energies will be constant, individuals' energy will be changed maybe. And there is also a contrary, not to this but to a different thing. If we take it to a different level, that if there is a loss of kinetic energy, if the whole kinetic energy was lost, then the motion of the particles will not be possible. It will come to rest without kinetic energy. It will settle down. But this is not actually observed. It will not settle down, they will actually move. Theory is just the explanation of experimental data, so you just have to remember the theory. At any particular time, different particles in the gas have different speeds and hence different kinetic energy. This assumption is reasonable because as the particles collide, we expect their speed to change. Even if initial speed of all the particles was same, the molecular collisions will disrupt this uniformity. Consequently, the particles must have different speeds which go on changing constantly. It is possible to show that though the individual speeds are changing, the distribution of specific remains constant, speeds remain constant at a particular temperature. So if we see on any particular time, every particle, like imagine that there is a certain time and you just get into the microscope and you look about the particles of the gases, you observe that they have very different speed. Every particle at the same point of time, they are identical but they have different speeds. And also it means that they have different kinetic energy, because kinetic energy is nothing but half mv square. So this assumption is reasonable. Why? This is an assumption that they have different speeds, therefore they have different kinetic energy. Why this is an assumption? This assumption is reasonable because as the particles collide, we expect their speed to change. Of course, there will be some exchange of individual energies when the two particles collide or the walls of the container or the particle collide. Even if initial speed of all the particles was same, the molecular collisions will disrupt this uniformity because we don't know that which particle will strike which particle and how much times it will strike, even if we start with the same initial speed. So it will disrupt the uniformity. The particles should have different speeds. So it is experimentally possible to show that the individual speeds are changing, the distribution of speeds remain constant at a particular temperature. If a molecule has variable speed, then it must have a variable kinetic energy. Under these circumstances, we can talk only about average kinetic energy. In kinetic theory, it is assumed that average kinetic energy of the gas molecules is directly proportional to the absolute temperature. So, if we consider a molecule which is having a variable speed, if there is a molecule which has variable speed, then it must have a variable kinetic energy. Of course, I told you earlier. So if we talk about average kinetic energy as the speed is changing continuously, in kinetic theory, we have an assumption over here that average kinetic energy of the gas molecules is directly proportional to the absolute temperature. Kinetic energy of the gas molecule is directly proportional to the absolute temperature. You can write it down or just underline it that kinetic energy is directly proportional to the absolute temperature. It is seen that on heating a gas at constant volume, the pressure increases. So whenever we heat a gas and there is a constant volume, the pressure increases. Obviously, the pressure will increase. It's increasing the temperature. On heating the gas, kinetic energy of the particle increases and these strike the walls of the container more frequently, thus exerting more pressure. Okay. Kinetic theory of gases allow us to derive theoretically all the gas laws studied in the previous section. Calculations and predictions based on kinetic theory of gases agree very well with the experimental observations and thus establish the correctness of this model. So there were how much? I know this is difficult to remember. There are 7 assumptions. Let's just recall it in a short manner. Firstly, we were explaining the compressibility of the gases. Here we studied assumption that explains the great compressibility of gases. First point, we studied that there is large number of identical particles which are very small and which are very far apart. So the actual volume, and if we consider those distances between the volumes, that is negligible. There are like as point masses, the atoms and molecules. Therefore, it explains the compressibility of the gases. And in the second point, we read that there is no force of attraction between the particles of a gas at ordinary temperature and pressure. As we already know, as we have this we have already studied in the point number 1, that the force of attraction between the particles of gas at ordinary temperature and pressure is absolutely nothing. And we can explain this on the fact that gases expand and occupy all the space available to them. Gases expand. So in the first point, we explain the compressibility of gases. In the second point, we are explaining that gases expand and occupy all the space available to them. And this is on the basis that there is no force of attraction between the particles of the gas at temperature and pressure. Of course, because of they expand, so that means that they have no force of attraction. They can expand to infinitely times. In the third point, we read that the particles of gases are always constant and in random motion. That why a gas do not have a fixed shape? Why the gas does not have a fixed shape? Because of the particles which are in constant motion and they are at not rest. Fourth point, we explain that collision of the particle. Pressure is exerted by the gas as a result of collision of the particles with the walls of the container. This we proved by taking an assumption that particles of a gas all move in the possible direction in straight lines. So how the pressure is exerted? So collision of gas molecules are perfectly elastic, and this was the before and after energy remains the same, and exchange of energy between the colliding molecules, their individual energies may change, but the sum of the energies remain constant. And if there were loss of energy, then the motion of the molecules will stop and gases will settle down. So this was and in the sixth point, we studied that at any particular time there is different speeds, different kinetic energies, and this is reasonable because the particle collide, we expect their speed to change. The distribution of speed will remain constant at a particular temperature. In the last point, we studied that the kinetic energy is directly proportional to the absolute temperature. We can see this from heating a gas at a constant volume. The pressure automatically increases, and on heating the gas, the kinetic energy of the particle also increases and strike the walls of the container more frequently, thus exerting more pressure. So kinetic energy will increase with the pressure, and pressure will increase with the temperature. So kinetic energy will increase with the temperature. So there are these 7 points that we read. We again revise it. the compressibility of gases, which can be explained on the fact that the volume is not this negligible if we consider that they are very small and they are very far apart. Okay, they all act as point masses. This explains the compressibility of gases. Then we explain the expansion of gases, how they expand. Okay, they expand they can expand because they are in constant motion, and therefore there is no force of attraction between them. Was the reason behind it. And the third, we studied that the kinetic energy will vary as a matter of temperature. As the pressure will increase, if the temperature will increase, and as the temperature will increase, the kinetic energy will increase. So kinetic energy is directly proportional to the absolute temperature, because when we heat, the temperature increases, the pressure also increases of the liquid. That was the last point, I guess. The fourth one, we studied that the individual speeds, the changes, but the distribution of the speeds remains the same. And we also studied that collisions of the gas molecules are perfectly elastic. And we also studied that why they don't have fixed shape, because they are always in constant and random motion, and pressure is exerted by the gas as a result of collision of the particle with the walls of the container. As the particles of gas move in all possible direction in straight lines. So this explains the correctness of this model. Every model is incorrect, but this model is somewhat correct. This ends our topic.